Okay, gang, so let's start the discontinuity part. For 3A, I mentioned in lecture that the sum and difference of continuous functions is a continuous function. So the sum and difference of a continuous function is a continuous function. So if you take e to the x, that is a continuous function. If you take sine of x, that is a continuous function. So these are both continuous functions. So if I add or subtract them together, the result will also be continuous. For 3A then, there's no discontinuity. This is a continuous function because you are adding together two continuous functions. 3B, that is the greatest integer function, otherwise known as the step function. It is shifted 2 units to the left. So for the standard step function or greatest integer function, it will jump at every integer for the standard one. Therefore, this one is discontinuous at every integer. And we would say that that's non-removable because that's a gap. Okay, so for some people they say x equals to n, where n is an integer. That's where it's discontinuous, but this is fine. So it's discontinuous at every integer. All right, gang, let me leave it. Oh, you know what? Let me see if I can squeeze in one more. And I wrote non-removable. Okay. Now this one is what we would call a piecewise graph. So at 5, anything less than 5, the numbers on this are pretty high. So I'm just going to really rough sketch this because these numbers are huge. I'm not going to scale this, okay? They're not huge, but you know, just relatively speaking for graphing, they're quite large. So anything less than 5 is this graph. So this is not going to be drawn to scale. Okay, this is a parabola. It's being cut off at 5. This is at a height of 525, right? Because if you plug 5 into here, that's 25 at 5. And then this other graph, if you plug 5 into here, it's at 19. So this graph is at 19 at 5. And again, this isn't drawn to scale. Oh, this one's solid because it has the bar. And this one's going to be open at 519, and it goes up with a slope of 3, so it's going to be going up. So this is just a really rough sketch, but this is what it looks like because at 5 it's not connecting, it has a gap. At 5 it has a gap. So we would say that this is discontinuous at x equals to 5, and we would say it's non-removable because it's a gap. If you remember the 3 conditions for continuity, I went over them in lecture. That's section 2.4. So remember the 3 conditions: that the point has to exist. So that's where it's equal. So like f of 5 has to exist. And then the two-sided limit has to exist, which it doesn't. Right? The two-sided limit as x goes to 5 of f of x has to exist. This doesn't exist because coming in from the left, it's 25. Coming in from the right, it's 19. And then the very last point would have been that the point had to equal the limit. Right? And we don't even get there because we didn't get past this. And that basically says that for it to be continuous, you have to make sure there's no, for the two-sided limit can't have a hole in the middle. That hole has to be defined. Again, so this is going to be discontinuous at x equals to 5. It's non-removable because you've got that gap. And again, you could go over the conditions for continuity from 2.4 if you don't remember it. The point has to exist, the two-sided limit has to exist, and the point has to be plugged in the two-sided limit. All right, gang, I'll catch you. Bye-bye.